Hi, everybody. All right, so there's a very real chance some of you are in the room with me watching this, hopefully in headphones or something. I don't know. We're going to figure that out. But I'm still going to create these videos. We really only have a few more. So we did horizontal axis of rotation, which worked like this to get volumes of these really bizarre solid objects. Today we're doing all vertical axis of rotation, rotating this way, which means we're using Y all day. So I will walk you through these. I think what I'm rather do than learn the last lesson on Thursday, Friday, we might do a practice day Thursday, Friday to really kind of get some of these under our belt. It's April 12th, 13th. We got a little less than a month. That's plenty of time. So I actually have a ton of time to review with you guys. We'll be doing FRQs. We'll start looking at multiple choice. So I'd rather spend a little bit more time on these rotation ones and then get to the last type of volume ones and then start doing FRQs on these and then just putting it all together and preparing for that AP test. But today we are doing volume by rotation, a vertical axis of rotation. So I only have two examples, but we'll do parts A, B, and C for each, I think, so that you can see how this is pretty much what we did last time, just a couple of differences. So area bounded by, here we go, y equals x squared, y equals 4, and x equals 0, otherwise known as the y-axis. It's another way of saying the y-axis. Rotated about, and then I will give you various axes of rotation. And let's find the volume. That's what we're doing on all of these, okay? So I will do a couple of examples, and in this case, they're all going to be vertical axis of rotations, which changes a few things. But a lot of the steps are going to be the same. So for your discussion, you're just going to add on to what you did last time, filling in how to work the problem if it's a vertical axis of rotation. All right, so part A, let's rotate about, in this case to start, the y-axis. All right, so step 0, or step 1, sorry, sometimes I have step 0s, but this is a step 1. Step 1 from last time was to graph, and find the bounds, and one other thing that I'm gonna add. So y equals 4 is here, y equals x squared looks like this, and the y-axis is here. So it's this guy. Okay. Keep it right there. So step 1 says to graph it, shade it, bounds. So from last time, we found the x bounds, so from here to here, and that's always a good idea because sometimes you'll be doing horizontal and vertical rotations. So the x bounds in this case were 0 to 2. But now we're going to add to this. We're going to find the y bounds from where the area stops or starts to stops in terms of the y coordinate. And this one starts at y equals 0 and end at y equals 4. So the y bounds are a little different. You should do that. One other thing. This function is y equals x squared. It makes sense to get the functions in terms of y now. Get them as functions of y. So we're going to solve for x, basically get x by itself. So we can square root both sides, and this is equivalent to x equals root y. So another way to think about it, and this is a little weird, we don't do this a lot, but we can talk about f of y, the function in terms of y, is square root of y. That is the equivalent to f of x equals x squared. So just like f of x really means y, f of y really means x. It just means you have the functions in terms of y in the top one. The bottom one, the functions in terms of x. Okay. Long story short, get x by itself so that we can do what we're going to do in the next step. Okay, so step 2 was that question of x or y. And we use x when it's a horizontal axis of rotation. So from last time, this is a horizontal axis. But today, we are doing entirely vertical axis. So we are rotating around the y-axis, which is right here. And if we are rotating around a vertical axis of rotation, we are using y, which means we can begin to build our answer. It looks like this. the volume is going to equal pi, don't forget the pi, integral, and we are using all y's now. So the y bounds, because we are doing a vertical axis of rotation. So 0 to 4 dy. Notice how it's y. Just like when we did right minus left for area, if we're doing a vertical axis of rotation, it's all going to be right left stuff. So here we go. Next step, 2 radii, 1 radius. 2 radii, 1 radius. Well, the same question. From where we're rotating, do you see any blank space right here? No blank space. There's no BS going on here. No blank space. The shaded region is sitting right on top of the axis of rotation, so 1 radius. So 1 thing squared. That's it. So what is the radius? Well, this is where you got to be a little careful. So let's go through this carefully. When you are rotating around, or let's back up. When you're talking about a function, the distance between the x-axis and the curve, that's known as f of x. That same rule applies if you're talking about the distance between the y-axis and the curve. That's called f of y. So your f of x value is always the distance from the x-axis to the curve. Your f of y value is always your distance from the y-axis to the curve. So in this case, this distance we're looking for, this 1 radius through the shaded region to the outer edge, is f of y, or the function value for the function you're working with, which is just radical y. So you come back, plug in radical y, and that's it. There's our calculation. Boom. And we can plug that into Desmos and find the answer. Or on the AP test, this is one that's not so difficult, so they may actually ask you to do this one by hand. So when you square root a squared, or square root, those cancel, and you are left with y dy. And then you could go from here and do all of this by hand. So we'll do this one by hand, and the rest we'll do Desmos. Antiderivative of y is y squared with a half in front, evaluated from 4 to 0 with a pi in front. So plug in 4, you get 16, because 4 squared is 16, divided by 2 is 8, so the answer looks like it is 8 pi. Now, on your homework on the last one, some of you guys kept the pi, some of you multiplied through and got rid of the pi. What's the answer? When do you keep pi and when do you not? I always say if you haven't rounded, don't round. So I didn't have to round to get the answer of 8, so just keep the pi there. If my answer had been something like 320.268 pi, then yeah, it doesn't make sense. You've already rounded this part. You may as well multiply through by pi and continue to round. But I didn't round 8, so you don't technically need to multiply by pi. Just keep it as 8 pi. That's a good answer. But if you do, it doesn't matter. At the end of the day, you can keep the pi or not. Either keep it or multiply it through. It doesn't make a difference. Okay. And let's check our answer real quick just to make sure that I'm firing on all cylinders. That's the next problem. We'll come back to that. Int 0, 4 of y. Remember, it doesn't matter what dy is 8. Yeah. It doesn't matter what variable you use in Desmos or anything. So yes, even on your graphing calculator, once you have the setup, just go ahead and use x's. Once you have the setup, just go ahead and use x's. It doesn't change. It's just a variable that gets taken care of in the problem. It's a variable that goes away upon completion of the problem. All right, let's do the exact same setup, but this time for part B, let's go around the line x equals -3. So the first one was the y-axis. This one's going to be on x equals -3. All right, so same logic. Let's just quickly resketch it. Wow, that's beautiful. Looks like this. The reason I like taking one problem and just doing it a bunch of different ways is this is what the FRQs tend to look like. They will give you one setup, and then you just got to do a bunch of different things. Okay, so around x equals -3, we still have our same bounds. We know we're using the y bounds in this case. 0 to 4 again. These are y coordinates. And we have this function, which is radical y. And this time we're rotating around x equals -3, which is way over here. And that is a vertical axis of rotation. People always get confused because they see x equals and thinks, oh, everything's in terms of x. No, x equals is a vertical line. That is a vertical axis of rotation. That's the way you think about it, a vertical axis of rotation. And then we are spinning this way. So it's all right minus left type of stuff. All right, so rather than state all the steps, we'll kind of go through this. We already know it's a vertical axis of rotation. So everything's in terms of y. So 0 to 4 again, dy. 2 radii, 1 radius. Well, if you look, I see a ton of blank space all right here. Lots and lots of blank space, which means there's a hole. If you were to actually see what this rotation looked like, it'd be like the tip of a rocket ship with a big hole through the center of it. And that means 2 radii. Big R squared minus little r squared. All right, so same steps I had you write before. That's the cool thing. It doesn't matter if it's a horizontal or vertical axis. It's exact same setup. To find big R, start at your axis of rotation, through the blank space, hit the inner edge, through shaded region, hit outer edge. Draw it one more time and see if it changed size. Through blank space, inner edge, outer edge. It's different, so that means it has something to do with the function. So, if you paid attention carefully last time, this will feel very similar. This distance right here, as I said in the last problem, is f of y. What is this other distance, though? Well, that's the distance that's not changing. That distance is just 1, 2, 3. So the whole big R in this problem is f of y plus 3. F of y plus 3. How about little r? Well, let's draw it. From where we're rotating through blank space, stop at inner edge. From where we're rotating through blank space, stop at inner edge. It did not change size, so that is just a 3. That distance is 3. And that's it. Plug it into Desmos, on your way. Okay, once you do enough of these, they all start to feel very similar. Oftentimes you are either expanding the length of the radius, or sometimes, we haven't seen a ton of these, you shrink the size of the radius. And you'll have to subtract out. We'll do more of those when we practice. It's hard to get all of them at the same time when we're learning this for the first time, but you'll see, especially when we start doing FRQs, you'll get a good feel for how these work. All right, so I lied. Let's just do an A and B for each one. So one more example. This video is a lot faster today, and then you get to try the homework. Let's say this one. Area bounded by, I have 2 curves for you. X equals y squared plus 2y, and x equals y plus 2 around, and we'll do 2 examples. The first one, let's go around x equals 5. All right, so let's take a look. First of all, notice that this one's already in terms of y, so I'm hoping we don't have to get x by it or y by itself, and we're not. We're going to do an all vertical on this one. So let's start by graphing. This one's a little bit more complicated. I am totally fine with you pulling up Desmos or your graphing calculator to see what these look like, especially because I didn't give you bounds, so you're going to have to find them. So x equals y squared plus 2y, and x equals y plus 2. Cool. So this is the shaded area. It's going to be this little thing inside. I'm going to draw it. So I'll keep it over here and sketch it for myself. Wow. Let's try that one more time. Beautiful. Okay. So it looks like something kind of like this. It goes through -2 and 2. Absolutely perfect. And then it intersects up here. And wow, let's try that one more time. Like that. Good enough, okay? That's the area we're looking for. And it's rotated around, in this case, x equals 5, which is way over 1, 2, 3, 4, 5 way over here. All right, this is one of the trickier ones. Okay, so first thing we need to do is we graphed it, shaded it, find the bounds. You can find the x bounds and the y bounds. Since we're only doing vertical axis of rotation today, I will just find the y bounds because that's all I'm going to need. So find where these two things intersect. You could either do that by setting them equal to each other and solving. Very rarely they'll have you do that. Let's try it. Why not? I know you really want to. To find where any two things intersect, you just set them equal to each other. So like if x is equal to this and x is equal to this, where the two functions in terms of y equal each other, that is one way to figure out algebraically where they intersect. So get everything to one side. So I'm going to subtract the y over, subtract the 2 over. Y squared minus y minus 2. Then you have to solve this. I think we can solve it by factoring. So minus 2 plus 1. So at y equals -1 and y equals 2. Do I do that backwards? No. Should be -2 and +1. What did I do wrong? Y. Oh, this is a positive. Fixed it. I knew something was wrong. Plus, which means this should be a minus. This should be, nope, that should be a plus. That should be a minus. There we go. Whew. Okay, so y equals 1 and y equals -2. Those are my bounds. So from -2 to 1. From -2 to 1. So that's where the shaded area starts and stops. All right, the volume is, well, vertical axis of rotation. X equals 5 does not mean to use x. It is a vertical axis of rotation, which means you are going to use your y's. So pi integral -2, 1 dy. Now, spoiler alert, oftentimes when you have two functions, you're going to have two radii. Very rare the case where you have two functions and only one radius. There's usually going to be blank space, lots of blank space here. So 2 radii. The nice thing is if you can find one radius, the other one's probably going to resemble the structure. So here we go. From where you're rotating, through blank space, stop at outer edge. From where you're rotating, through blank space, stop at outer edge. This is one of the most confusing types because I almost think it's easier to do this. Because when we start working in the negative side of things, so like in the negative quadrants for y or the negative quadrant for x, people tend to get confused. I would try to get it to stop at somewhere that's there on the positive side and think about it this way instead. So what is this distance in green that I'm drawing over and over and over? Well, remember, this distance between the y-axis and the curve, this is f of y. So the distance I want in green is the whole distance minus f of y. So it is the whole distance of 5 minus f of y. Well, which curve are we talking about? We're talking about the parabola in this case, which was the y squared plus 2y. So minus, be careful here too, y squared plus 2y. All right, so let me just really quick talk about this. People get confused because they're like, wait a minute, if I drew it here where you did with the green, shouldn't it be 5 plus f of y? No, because in this area, this distance is still f of y. It's just f of y is negative in this section. So if you think about the actual value here, it is a negative. So if I do 5 minus f of y in this little section, you're subtracting a negative value. So it's like 5 plus some value. So no, at the end of the day, always remember f of y is the distance between the axis and the curve. And when it's positive, you're making it smaller. When the f of y value is negative and you're subtracting it, you're making it bigger. So I guess the real long story short, at the real end of the day, try to keep things positive. It just helps your mind to recognize it easier. So again, I would go back to this guy right here, thinking about this distance. This one I drew in blue, this dotted line in blue is f of y. This big red distance is 5 minus f of y. But if you can wrap your mind around that, little r is going to follow suit. So check out little r is through blank space, stop at inner edge. Same deal. This distance is f of y. So the distance we want is 5 minus the other function, which is y plus 2. I shouldn't say function. They're not well, this one is actually a function, but the first one's not, because you have two outputs for an input. And then keep it in parentheses, and that's it. And again, you can find the value, which is just as simple as plugging into Desmos. You may actually want to try plugging this one into your graphing calculator, because these are the most common mistakes. It's really frustrating when you come back. It's really frustrating when you know what you're doing and then you just plug it into your calculator wrong. Typically, these FRQs are worth 3 points. One for the bounds, one for the setup, and then a point for actually finding the right answer, because people mess up the answer all the time. So what you can do is int -2 to 1. FYI, I think I figured out how to get it so I can show you my calculator on the screen. I'll play around with that next week while we're in class. 5 minus, again, I'm going to do that thing where I just switch back to x's. Just to remind you that that's a thing. So that whole guy squared. So really need parentheses on this one. Minus little r, minus parentheses 5 minus parentheses y plus 2 squared, close, nope, squared, close the parentheses, dy. dx, not dy. I'm just leaving it fun. That's funny. dx, x, 124. Okay. So taking this guy and rotating it, 124.4, rotating around x equals 5. If I plugged everything in correctly. If I messed something up, you can go back and look. I don't think I did. Plus 2x. That whole thing squared minus, and then same thing. These ones are harder to tell in terms of the volume you're going to get, because it feels like it shouldn't be that big. But I think that's correct. I feel like that's really big, though. But then again, it is cubic units. So it's really hard to visualize, because one is right here. It is hard to visualize that. But then again, you also are making it pretty big with this hole cut out. Is probably fine. But if anyone notices something I typed in wrong, because for some reason it's not jiving perfectly with me. 5 minus x squared plus 2x. That whole thing is squared. No, I think it's fine. Anyway, okay. Setup is why I really want to see it, because I know the setup's right, so it must be right. Okay, actually, I think I'm going to stop there, because the other ones are similar. You just got to get that. So, like, I did one on this side of the axis. I did one on this side. And I did the y-axis. That should be enough to kind of get you started. And I think Thursday, Friday, we will practice some of these together. We'll hit a slew of them. Whether you're in class with me or sitting at home, that's what we'll be doing. All right? All right, I think that's it. Anything else I wanted to mention? I feel like there was, but now I can't remember. No. All right, that's it.